So what I can do is I can use my properties of exponents over here. So right now I'm in this form. I'm going to rewrite it like this. So you take log base 10 of the numerator minus log base 10 of the denominator. So that h plus, we're kind of treating that as like our little variable that we're trying to find. And we know it comes out to equal 5.5. So we can start to simplify some of these things up, because this right here, log base 10 of 1, remember this is the exponent that I would put on 10 to give me an answer of 1. And that would be an exponent of 0. Okay, so anytime you see a 1 in here, you know the answer is just going to be 0, because anything raised to the 0 power gives you 1. This right now is telling me that 10 raised to the 0 power gives me an answer of 1. So I have 0 minus this log property right here equals 5.5. Okay, so the next thing to do is this is now 0 minus. Okay, so I can take this negative, because I don't want it to be a negative, and I can add it over to the other side of the equation. All right, actually, the best thing to do would be to just multiply everything by a negative. That'll save us a couple steps. So this is now positive. This right-hand side will now be negative, because I multiplied everything through by a -1. And then when we want to get the h plus by itself, we're going to convert this into our exponential form. So we've got 10 raised to the negative 5.5 power, comes out to be the concentration of hydrogen. Okay, so if I just plug that in, I will end up with the h plus. So 10 raised to the negative 5.5, that gives me approximately point, and then 1, 2, 3, 4, 5 zeros before the 3. All right, so that would be your final answer. All right, and last one, the power property of logarithms. This one tells me if I have log base a, and on the inside, say I have x raised to the power of m. This is telling me that I can just move that power of m out front and treat it almost like a coefficient. Okay, like that. And that connects very closely to the last and final property of exponents that we wrote down, the one that tells us if I have a power raised to a power, then I can just multiply the two of those powers together. So remember, like this represents a power. Logs represents a power, and then I'm raising it to a power, so I can treat it as this power multiplied by this, which represents a power. So again, very closely linked back to those original properties of exponents that we learned about. Now, one more of these, this is just like example 1. Given log base 5 of 6 is this approximation, we want to approximate the value of log base 5 of 216. So what I can do, since I'm trying to connect it back to this, I can write this as log base 5 of 6 to the 3rd. Okay, so 216 we know is 6 cubed. So right now I'm in this form right here. To transition it into this form, I take this 3 and I move it out front to multiply, just like I have here. So this is 3 times log base 5 of 6. And I know that log base 5 of 6 is about 1.1133. Okay, and I can just multiply all that together. So multiply everything by 3, and I will have 3.3399. So it's saying that this is the power that you could raise 5 to in order to get about 216. It's an approximation, but I'll show you anyway. So if I take 5 and raise it to that power, about 3.3399, I should get just about 216. Okay, which I do. Again, it's all an approximation, but it does come pretty darn close. All right, so that's it for the first half.